Are the words velocity and speed synonymous? Yes, they are in our day-to-day language. However, in science, they are not. Speed is a scalar, whereas velocity is a vector. Speed has only magnitude, whereas velocity has magnitude as well as direction. Speed depends on the magnitude of the path length described by a body and the time taken to describe this path. Velocity, on the other hand, depends on the displacement of a body and the time taken for this displacement. Let's start with average velocity. A body moving in a straight line is said to be in a rectilinear motion. Let's plot an xt graph of this motion. A body starts at the origin and travels through a certain distance x meters in time t seconds. Let us mark 2 points A and B on the graph obtained. Let us study the motion of the body from point A to point B in detail. x1 and x2 are the positions of the body at time t1 and t2 respectively. The displacement delta x is the difference between x2 and x1. The time interval delta t is the difference between t2 and t1. The average velocity is the ratio of the change in position or displacement delta x and the time interval delta t in which the displacement occurs. The SI unit for velocity is meter per second. The velocity of vehicles is generally expressed in kilometers per hour. Let us take the readings from the graph and calculate the average velocity of the body from point A to point B. Delta x is equal to x2 minus x1 is equal to 42 minus 10 is equal to 32 meters. Delta t is equal to t2 minus t1 is equal to 7 minus 3 is equal to 4 seconds. V bar is equal to 32 by 4, which is equal to 8 meters per second. V bar represents the slope of the line joining points A and B. Slope is equal to tan theta is equal to x2 minus x1 by t2 minus t1. If you observe the graph carefully, you will find that the displacement is different in different intervals of time. That is, from the 3rd to the 4th second, from the 4th to the 5th second, and so on. For calculating the average velocity, we take the total displacement and total time elapsed. In other words, it is the average of different velocities obtained at different instants of time. For example, when a car is traveling on a straight road, the velocities at various instances of time, say t1, t2 and t3, are taken as v1, v2 and v3 respectively. Then the average velocity is the average of the 3 velocities recorded. Let us consider a scenario where a person is traveling from his home to his workplace and back home in his car. The path traversed by him is a straight line. When he goes to work, the displacement of the car is equal in equal intervals of time. Here, the displacement is considered to be in the positive direction. The xt graph, when plotted for this motion, is a straight line passing through the origin and making a positive acute angle theta with the time axis. The car is in a state of rest or at the same position for some time as long as the man is at his workplace. For that time span, we get a straight line parallel to the time axis when plotted on the graph. When the man returns home, the car makes equal displacements in equal intervals of time, in the negative direction. The graph now is a straight line, making a negative slope with the time axis. When the total displacement of the car is considered, it is 0. We know that speed depends on the magnitude of the path length described by a body and the time taken to describe this path. Average speed is the ratio of the total path length and the total time taken for the motion. The unit for average speed is the same as that for average velocity. That is, meters per second or kilometers per hour. When a body moves in a straight line in the same direction throughout its motion, the magnitude of the displacement is equal to the total path length. In such a case, the magnitude of the average velocity is equal to the average speed. Joe travels by a car from his residence to his office, which is 15 kilometers away on a straight road, in 1 hour. We can say that the average velocity of the car is 15 kilometers per hour. Does the speedometer of the car show a reading of 15 kilometers per hour throughout the journey? No. The speedometer reading was fluctuating continuously between 0 kilometers per hour at signals, 5 kilometers per hour at traffic jams, and 60 kilometers per hour on the freeway. When a body moves in a straight line, the magnitude of its velocity is equal to its speed. The speedometer reading gives the instantaneous velocity at that particular moment. What is instantaneous velocity? The velocity at an instant or instantaneous velocity is defined as the limit of the average velocity as the time interval, delta t, becomes infinitesimally small. In differential calculus, the right-hand side of this equation is called the derivative of x with respect to t. It represents the rate of change of position with respect to time at that instant of time. We can obtain the value of instantaneous velocity either from the xt graph or numerically using differential calculus if the relation between x and t is known for the motion. Let's understand how to calculate instantaneous velocity using an xt graph. We first mark a point P on the graph at which the instantaneous velocity of the body has to be found. We mark 2 points P1 and P2 on either side of P. Join points P1 and P2. Find delta t and delta x. When delta t is reduced, we get lines Q1, Q2, etc. On further decreasing the value of delta t, we finally get one line, which is the tangent to the curve at point P. The slope of this tangent represents the instantaneous velocity at point P. Slope is represented by tan theta as shown in the graph. This graphical method of finding the instantaneous velocity at any point is cumbersome. Therefore, we generally use the numerical method using calculus for finding the instantaneous velocity at any point. Let's solve a problem using this numerical method. The position of a particle that moves along a straight line is defined by the relation x is equal to t cube minus 6t square minus 15t plus 40, where x is expressed in meters and t in seconds. What is the instantaneous velocity at t is equal to 0 second and t is equal to 2 seconds? What is the average velocity between t is equal to 2 seconds and t is equal to 4 seconds? Solution: the equations of motion are x is equal to t cube minus 6t square minus 15t plus 40. V is equal to dx by dt is equal to 3t square minus 12t minus 15. Label these equations 1 and 2. At t is equal to 0 seconds, we need to find the value of v. Substituting t is equal to 0 in equation 2, v is equal to minus 15 meters per second. The particle here is moving towards the left. At t is equal to 2 seconds, we need to find the value of v. Substituting t is equal to 2 in equation 2, v is equal to 3 multiplied by 2 square minus 12 multiplied by 2 minus 15. 12 minus 24 minus 15. Minus 27 meters per second. The particle here is moving towards the left. Average velocity is equal to x4 minus x2 by 4 minus 2. To find x4, we need to substitute t is equal to 4 in equation 1. x4 is equal to 4 cube minus 6 multiplied by 4 square minus 15 multiplied by 4 plus 40 is equal to minus 52 meters. The particle is situated to the left side of the origin. Similarly, to find x2, we need to substitute t is equal to 2 in equation 1. x2 is equal to 2 cube minus 6 multiplied by 2 square minus 15 multiplied by 2 plus 40 is equal to minus 6 meters. The particle is situated to the left side of the origin. Average velocity is equal to x4 minus x2 by 2 minus 52 minus of minus 6 by 2 is equal to minus 46 by 2, which is equal to minus 23 meters per second. Therefore, the average velocity between t is equal to 2 seconds and t is equal to 4 seconds is minus 23 meters per second. When you observe the motion of an electric train, you find the train picks up high speed even before leaving the platform. The train travels at constant high speed until it approaches the next station. There is a sudden drop in speed when it enters the station till it finally stops. The first and the last part of this train's motion has high positive acceleration and very high negative acceleration or retardation. Acceleration of a body is the rate of change of its velocity with time. The average acceleration A dash is defined as the change of velocity divided by time. V2 and V1 are instantaneous velocities at times t2 and t1. The SI unit of acceleration is meter per second square. On the VT graph, the average acceleration is represented by the slope of the line joining the points v1, t1 and v2, t2. Just as we defined instantaneous velocity, we can similarly define instantaneous acceleration. On the VT graph, instantaneous acceleration at any point on the curve is represented by the slope of the tangent drawn at that point. Like velocity, acceleration is also a vector with both magnitude and direction. The acceleration of a body can change with either a change in the magnitude of its velocity or change in the direction of its velocity, or both. In rectilinear motion, we have only two directions of motion, positive and negative. Therefore, we have two types of velocities, positive and negative. Similarly, we have two types of acceleration, positive and negative. Formulating a proper and consistent sign convention for acceleration is very important. Let's understand what constitutes positive and negative acceleration. Zero acceleration stands for uniform velocity. That is, the velocity does not change with time. Let us consider cases where acceleration is positive. Case 1. Let us consider a body, say, a car moving along a straight line. That is, from point A to B, with increasing magnitude of velocity. The body is said to be moving in the positive direction. Here, delta V is positive and direction of motion is positive. Therefore, with these two values being positive, acceleration is also positive. Case 2. In this case, the car is moving in a negative direction. That is, from point B to A, with a decrease in the magnitude of velocity. Here, delta V is negative and the direction of motion is also negative. Since the product of two negative values is positive, acceleration in this case is also positive. Let us now consider cases where acceleration is negative. Case 1. Now consider the car moving in a positive direction. That is, from A to B, with a decrease in the magnitude of velocity. Here, delta V is negative and direction of motion is positive. Since the product of a negative and a positive value is negative, the acceleration in this case is negative. Case 2. In this case, the car is moving in a negative direction. That is, from B to A, with an increase in the magnitude of velocity. Here, delta V is positive and direction of motion is negative. Since the product of a positive and a negative value is negative, the acceleration in this case is also negative. To decide whether acceleration is positive or negative, the terms retardation or deceleration are confusing while solving problems. Here is an easy way to get the sign convention for acceleration right. In the four cases we have just studied with respect to points A and B between which the body traverses, let us fix the velocities of the body at these points as V at A and V' at B. The four cases are tabulated. If the origin and direction of motion are discarded, we are left with the type of acceleration and the relation between the velocities at 2 points. if v and v dash are taken as the initial and final velocities in any given problem. Then, if v is less than v dash, then acceleration is positive, else negative. Let us see what the xt graphs for positive, negative and zero acceleration look like. The xt graph for motion with positive acceleration curves upward. For negative acceleration, it curves downward. For zero acceleration, it is an inclined line. Let us see what the vt graphs for all four cases explained earlier look like. Body with positive acceleration, that is, positive direction and positive velocity. The graph is an inclined line above the x-axis with upward inclination. Body with positive acceleration, that is, negative direction and negative velocity. The graph is an inclined line below the x-axis with upward inclination. Body with negative acceleration, that is, positive direction and negative velocity. The graph is an inclined line above the x-axis with downward inclination. Body with negative acceleration, that is, negative direction and positive velocity. The graph is an inclined line below the x-axis with downward inclination.